Hello, let's see this interesting question of GMAT. T equal to $6.8 AB8 if A and B denote the hundredth and the thousand digits respectively of the sum of money T, what are the values of A and B? Statement 1. If T were rounded to the nearest cent, the result would be $6.85. Statement 2. If T were rounded to the nearest tenth of a cent, the result would be $6.85. Great guys, let's tackle this problem and see the concepts involved. GMAT is all about concepts and their application to problems, logical thinking and logical inference from one statement to the next. We will see all of the above playing out in this problem. Here we have an interesting question. Let's go through some basic concepts we need to solve this problem. First, let's see the concept of decimals and rounding. So, the concept of decimals and rounding. Let's start off with one example to understand it and refresh our memory. We'll start with 123.245. In this number, if I ask you which digit is in the 10th place, what would be your answer? Yes, it is 2. The 100th place, the digit in the 100 places, it is 4. 3 is in which place? Yes, it is units. Notice that before decimal we have the units place, then the tens place, then the hundreds place, and after the decimal we have the 10th place, then the 100th, and then the 1000th. Note that there is nothing like the unit place. Also notice that before the decimal the places have an S at the end, and after the decimal the last letters are TH. Great. Now let's go to the concept of the rule of rounding. If we are rounding a number to the 10th place, we need to see the digit to its right, that is the 100th place. If we find the digit in the 100th place is greater than or equal to 5, we round the 10th digit up by 1, and if we find the digit in the 100th place is less than 5, we keep the digit in the 10th place as it is. The same rule applies for rounding to any place. For example, if we are rounding the above number to the 10th place, we will leave it as 123.2. That's right, because next to 2 is 4, which is less than 5. But if we are rounding to the 100th place, we will make it 123.25 as the digit to the right of 4 is 5. Try a few questions now to make this clear on your own. What would be 125.354 rounded to the nearest 10th? Answer is 123.4. Since the digit to the right of 3 is 5, we have to round 3 up to 4. How about this question? What would 123.354 be if it is rounded to the nearest 100th? Now notice that 100th place is 5 and to the right of it is 4. So now when we round it, we will leave 5 as it is, and the answer will be 123.35 as the digit in the 1000th place is less than 5. Great. Now let's move to the next concept. Rounding to cents. What does rounding to cents mean? It simply means we round it off to the 100th digit after the decimal place. For example, $123.245 would round to the nearest cent will become $123.25 as we are rounding it to the 100th, and the digit to the right of 100th place is 5. Hence we will round the 4 up and make it 5, 123.25. Rounding to the nearest tenth of a cent means we round it off to the 1000th digit after the decimal. For example, $123.2456 rounded to the nearest tenth of a cent would become 123.246. Why? Because we are rounding to the nearest thousandth. The 1000th digit is 5 and to the next is 6, which is greater than 5. So we round the 1000th digit up by 1 and make the 5 6. And what is the reason for this? Reason for the above is that the 100 cents make $1. So when we are rounding to cents, we are rounding to the hundredths place, and when we round to the tenth of a cent, we round to 1/10 of 100, which is the 1000th place. Great. With these two concepts, we are now ready to tackle this problem. Let's check the statement 1. Statement 1 says that t rounded to the nearest cent would be $6.85, and if we apply the above two concepts of rounding and the corollary of the rounding to the cents and the nearest tenth of a cent, we will get statement 1 implies if t were rounded to the nearest cent, the result would be 6.85, and which in turn implies that 6.888 rounded to the 100th place, we will get 6.85, which in turn implies that 100th place A will be either 5 if the next digit, that is B, is less than 5, or the 100th digit, which is A, will be 4 if the next digit B will be greater than equal to 5. So here it's a very important step, and make sure that you understood and you applied the concept properly and you got its application. Basically what we have done is we've just applied the above two concepts, rounding to the thousandth and hundredth, and rounding to the cents and rounding to the nearest cent. Now thus from the statement 1 we do not get a definite answer for this question. A can either be 4 or 5. We do not get any idea about B. Thus, we can say that statement 1 is not sufficient, or NS short form. Now, let's check the statement 2. The statement 2 says that we are rounding to the nearest tenth of a cent, and that means, as we've discussed earlier, we are going to round to the nearest thousandth. Great. So, let's see the statement 2. So statement 2 says, if t were rounded to the nearest tenth of a cent, the result would be 6.85. Now, very carefully notice that this implies that when we are rounding 6.888 to the thousandth place, the value is 6.85. Now, thousandth place, since there is no digit, it is 0. So therefore, it in turn implies that it was originally 6.8498, since only 6.8498 rounded to the thousand will become 6.850. Now just notice here carefully, and can you understand this and can you explain this? What's the reason? The thousandth place, we are rounding to the thousand. Look at the thousand digit, it is B. Next to B is 8, hence B has to be rounded up. When we round B up, the next digit, which is A, will also when we have to look at the digit to the right of thousand place, which is 8, right? Thus, when we round to thousandth, we will have to round 9 up to 10. The 1 will carry over to the left, and we will get the result as 6.85. Pay careful attention to the above logical deductions. Make sure you understand them. Is there any other option to this? Because, for example, let's say if it was A was originally 5, right? And let's say B was originally 0. Now, if it was in that case, you are rounding to the thousand, your 0, which is in the thousand place, will get rounded up to 1, and you will get 6.851. But we have the answer that it is 6.85, so that will not work. Is there any other option? A can only be 4 or 5, right? Now, if A has to be 4, then B has to be 9, and there is no other option for A and B. Thus, it implies that A is 4 and B is 9. Since we are giving one definite answer to the required question, we can thus say that statement 2 is sufficient, or short form S. Now, since 1 is not sufficient and 2 is sufficient, we can conclude that the answer is B. Great, we have cracked it. It's an amazing question, and through this one question we have learned many concepts and seen how GMAT makes you apply them as well. Let's look at what if scenarios. Let's play out this question further to see what happens if we change a little bit of the question here and there. It's always good to play with questions and try and create a few additional questions from the question itself. This way you will have mastered the concept and its application. What if in this problem statement 2 was, if t were rounded to the nearest tenth of a cent, the result would be 6.852. Would this statement also be sufficient? Analyze and come up with your answer. Think about it. Yes. If you said yes, then you're correct. As we are rounding to the thousandth, we are going to take the digit a and make it 5. And since to the right of the thousandth place we have 8, we know that the rounding has to happen and we are going to round it up. And so we can say safely that b was originally 1 and a is untouched and it is 5 since we are rounding it up. Thus we get a definite answer that a is 5 and b is 1. Great. So hope this question is clear. I would like you to review it once again and go through the entire solution. Make sure that each and every step is clear, and you can even create 1 or 2 additional questions which will help you to completely master this concept and its application.